In this section, we're going to look at how to find all the zeros, which is the x-intercepts of a polynomial. And this will help us eventually with our graphing. So for graphing, we always need to think about our end behavior. We need to think about our y-intercepts. Or their y-intercept, there's only one, and then the x-intercepts, and there can be many. And then we often look at additional points as well to help us with our graphing. Okay, so this section is all about those x-intercepts, the zeros. So the zero, or the rational zero theorem, basically says if you take all the factors of your constant term, I'm going to call that C, and all of the factors of your leading coefficient, we're going to call that L, and you would just divide all those possible factors, and that would give you a list of all the different possible rational zeros. Okay, so let's do an example. All right, so here is my leading coefficient, so that's my L, and my last number is -4. Okay, so to list all the possible rational zeros, we would list all the possible factors of -4, and then we're going to divide that by all the factors of 1. Okay, so that would give me plus or minus 1, plus or minus 2, plus or minus 4. Those are all the different ways we can get to -4 if we divide it by either a positive or a -1. Okay, so if we're going to actually figure out like what are all those division problems, we'll basically dividing by 1 just doesn't, it would leave us with 1 obviously, but dividing by -1 would change the sign, but we're taking care of that here because we're saying it's positive or negative. So there's all the different possible rational zeros. Now we're going to use that information to try and factor. Okay, so what we're going to do is divide by our polynomial. We're going to use synthetic division to divide by one of those factors. I'm going to give myself a little bit more room. Okay, so here's my polynomial, leading coefficient of 1, 4, 3, -4, and -4, and I'm just going to start with the easiest one. If x equals 1 were a 0, I'm just going to check. Okay, so bring down the 1, multiply 1 times 1 is 1, add those together, multiply 1 times 5 is 5, add those, multiply 1 times 8, and add those, we'd get a 4, 1 times 4 would be 4. Okay, so we have a remainder of 0. That means that x equals 1 is a 0. So we can factor that as x minus 1 times this, and this would be, let's see, we started off with a 2, power 2. Okay, so then this would be x cubed, x squared, x. So go ahead and write that. So it would be x cubed plus 5x squared plus 8x plus 4. All right, well that's still not completely factored, so let's try now dividing. Let's try dividing this polynomial and see if that's divisible by one of our possible rational factors. So let's see, let's just try -1. I'm just going to start with the smallest numbers. So I've got leading coefficient here is 1, and then 5 and 8 and 4. We bring down our 1, and -1 times 1 is -1. Add these together. -1 times 4 is -4. Add the 8 and 4. And -1 times 4 is -4, and add those. Okay, so this gives me a remainder of 0, so x equals -1 is also a 0. So that means that we could factor it as x minus a negative would be plus 1. Okay, this started at 3, so I'm going to have, this would be 1x squared plus 4x plus 4, and then that I can see that would factor x minus 1 and x plus 1, and that actually factors as x plus 2 quantity squared. Okay, so mission accomplished. I factored it, and so I did that. Now I just need to list all of the real zeros. So the zeros are x equals 1, -1, and -2. Let's do one more example like this. So let's see, we're going to take, for the first part, we list the factors of our constant term divided by the factors of our leading coefficient. So that would be plus or minus 1, 2, all the different ways of multiplying to get 4. And we would have 1 or plus or minus 3. Okay, so if I'm dividing all those numbers in the numerator by positive or negative 1, I would just get positive or negative 1, 2, and 4. Should be a 4. And then if I divide 1 by 3, I would get a third, 2 by 3, 2/3, 2/3, and plus or minus 4/3. Okay, so those are all my possible rational zeros, and to factor, I'm just going to start with the easiest one. Maybe x equals 1 is a 0. Maybe not, but we'll just try. Okay, this is where I use synthetic division. So I'm looking at all my coefficients here. 3, -5, -8, 10, and 4. Okay, gonna list those. 3, -5, -8, 10, and 4. Bring down my 3. And then I multiply, so I get 3, and then I add. I multiply 1 times -2, and then I add -8 plus -2. Multiply and add. Multiply and add. Okay, so this is not a 0. That's okay. There's many, many more to choose from. Okay, so let's try, I could do -1. I'm just going to try maybe 2. Okay, so gotta start with those original, and we'll try it again. So let's see, we'd get 6 and 1, 2, -6, -12, -2, and -4. Good deal. So we have a 0 for a remainder, so that means x equals 2 is a 0. So then our polynomial could be written as x minus 2. Okay, and then I look up at my original coefficient, or my original power, so this would be 1 less, so these would be cubes, squareds, x's. So this would be 3x cubed plus x, I don't really need to write that 1, but it doesn't help, it doesn't hurt, x squared minus 6x minus 2. And I actually think I can do a grouping here. X minus 2. If I factored out an x squared from this little group, I'd be left with 3x plus 1. And then from this little group, I'm going to factor out a -2. I'm left with 3x plus 1. X minus 2. And then I'm going to factor out my 3x plus 1, and I'm x squared minus 2. All right, so I did my factoring, and now I just need to list those zeros. So we have 2. This one would give me, right, 3x plus 1 equals 0. So subtracting 1, dividing both sides by 3. And then this one would give me x squared minus 2 equals 0. Add 2 to both sides, so it would be positive or negative square root of 2. There we go. Okay, so that works great, but what can happen is if, like in this case with 12s, it just gets, there's so many possible different factors of 12, and then if you divide that, if we also have a leading coefficient that's got a lot of factors, you can just start imagining all the different possible combinations here. We could have 1, we could have 1/2, we could have 1/3, 1/4, 1/12, we could have 2, 2/3, let's see, 2/4, we already got a half, 2/12, that's a sixth, we don't have that one yet. We could do, let's see, 3/2, we don't have that one, right? So there just starts to be so many different, 3/4, oh, that was not a 14, but there ends up actually being 15 different things on this. 3/4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I only have 10 of them. Yeah, but there just becomes, it becomes ridiculous that we're not going to actually try and factor and keep using synthetic division for all of those. So there is this upper lower bound theorem that can help. And the big idea is when you go to divide, if you come down and you notice that all of these are they're non-negative, they're all positive, or they could they have to be not negative. Okay, so you could have a 0. That means that that's actually the whatever you're dividing by is the upper bound. It's the largest number that's going to be a rational divisor. Okay, and then here, these all have alternating signs, and so this number that you're dividing by, that x equals -3, is the smallest rational divisor, or smallest rational 0. Okay, so that kind of helps narrow it down just a tiny bit. So let's do a few examples using that idea. And just to reiterate, just one more quick time before I just notice that it's no negatives. And I know that sounds kind of weird, but the idea is just basically it could be a 0 or anything positive, okay? And then the other thing here is if we had had a 0, these 0 counts as a sign change. So this would be positive and then not positive, positive, not positive. And then this would be not negative. Okay, so zeros do count as a change in the sign. Zeros can counting as alternate signs. Here we go. So we're going to list all the possible rational zeros. So we're going to list all the different ways to get to 6. So 1, 2, 3, and 6. And then all the different ways to get to 1. And then simplify those fractions. 1, 2, 3, and 6. So I listed them all. Now I'm going to find my integer upper and lower bounds. Okay, so I'm just going to start, I like to just start with the number 1. It's just an easy place to start. Okay, so I'm looking at power of 4, and my coefficients are 1, 1, -7, -1, and 6. So I'm going to write all those numbers down. 1, 1, -7, -1, and 6. Do my synthetic division, multiply and add, multiply and add. Okay, so then 1 times -5 is -5, and adding those. Okay, so we got a remainder of 0, so that means that x equals 1 is a real 0. Okay, but what we're trying to do is actually find our our upper and lower bound. So let's go to our next bigger possible 0. And notice that these numbers are the same as our original. We're not factoring, so we're not changing the polynomials as we move along. We're just continuing with that same polynomial. All right, so multiplying, and then we add those up. And 2 times -1, -3, -6. Okay, good. So this is another 0. But what I'm looking for is my upper bound, and to be an upper bound, it has to have all these numbers would need to be positive along here, which they're not. Okay, so keep going. Let's try another one. The next bigger number is 3. 1, 1, negative 7, just copying those down, bring down our 1, and then we start our process to multiply 3 times 1, and add 3 times 4, and add 3 times 5, and add 3 times negative 14. Oh, that's a positive, is 42, and then add. And notice these are all not negative. Okay, so it could have been a 0 in there, and that would still let us know that 3 is the upper bound. Okay, good to know. Great, so we've done part of that. Now let's work on our lower bound. So my easiest number smaller than 1 is negative 1. So I'm going to keep those same tried and true coefficients here. And here we go. Negative 1 times 1. Add those up. Negative 1 times 0. Add those up. Negative 1 times negative 7. Add those up. And we have a 0. Okay, but I'm looking for a lowered bound, which means all of my numbers would have to be alternating in this line, which they're not. Okay, so that's fine. We'll just do our next smaller negative number. 1, 1, negative 7, negative 1, and 6. Okay, multiplying. Negative 2 times 1. Add them up. Negative 2 times negative 1. Oh, let's see. Negative 2. Oh, this would be positive. Okay, I thought I made a little mistake there. Okay, so that's not, oops, that is not what we want. That should be a negative 5. Okay, negative 5, 9, negative 18. What is that? Negative 12. So it's not a 0, and it's also not quite alternating. So we gotta just keep going. 1, 1, negative 7, negative 1, and 6. Bring down our 1. Multiply and add. Multiply and add. Multiply and add. Good. Okay, so I have now positive, negative, negative. Oh, okay, so I have a 0, but I don't have a lower bound yet. I'll just get this whole process up. So let's try our next possible factor. Oops. All right, 1, 1, negative 7, negative 1, and 6. Negative 6, and add those up. 30, add those up. Oops, that should be 23. 23, and that's positive. Negative 138, add those up. And 834, and add those up. Okay, so it's not a 0, but I do have a positive and then a negative, a positive and then a negative. Okay, so negative 6 is my lower bound. Okay, so put those pieces of information together, our upper bound, our lower bound, and that lets us know that all real zeros fall in the interval between negative 6 and 3.